Hello, how you guys doing? So we're here to talk today about Headless Chrome and Puppeteer. How many people have heard of Headless Chrome? My job here is done. What about Puppeteer? How many people are using Puppeteer? Okay. So hopefully by the end of today, we'll know a little bit more for those that don't know what Headless Chrome is or maybe just heard about it, what the heck that means, what Puppeteer is, how that fits in the equation, and talk a little bit about the dev tools as well. So my name is Eric Bidelman, as Peter mentioned. It's at eBidel on GitHub and Twitter if you want to follow me or ask me questions after the event. I'm an engineer on the Chrome team, but I also help web developers basically ramp up on the latest and greatest of the web platform, new APIs. Lately, I've been focused on testing in Headless Chrome and Puppeteer because I think it's a really kind of cool, exciting new space. But just to get this out of the way, this talk is not about testing. It's definitely not about testing. I think testing is great. You should all do it. You should do it constantly. You can certainly use Headless Chrome to do end-to-end testing or smoke test or test your UI of your application. But I want to focus on a different kind of aspect of it, which is automation, kind of telling Chrome what to do, automating it through script, kind of building it and bringing it in as a tool to your kind of workflow. That's what I did when building an app, and I think it actually is a game changer. There's a lot of cool stuff you can do with this. So my realization was that Headless Chrome can literally be a front end for your front end, and I'll show you a couple examples of what I mean by that. This was kind of a double rainbow moment for me. I was like, oh crap, this is awesome. This is not just a testing tool. Testing is boring. Again, you should all do it. But automation is the name of the game here, and I think some of the cool stuff I'm going to show, some of the demos I'm going to show kind of will hopefully explain that. So today's talk, we're going to talk a little bit about what Headless Chrome is, what that even means to be in the headless mode of Chrome. We'll introduce Puppeteer, the library that the Chrome team has been building for the past maybe one year. It's a node library, and kind of introduce its API just by showing some demos and some use case-driven things you might actually do when building an app or a script. And then just go through a list of cool stuff. So 10 interesting things that I found. Of course, there's many more things you could do, but these are the 10 cool things that I found for the talk. So in order to break this down today, let's kind of go through kind of the architecture of where all this stuff fits in. This is the pyramid of Puppeteer. At the very bottom of our architecture is just going to be Chrome. It's going to be Headless Chrome, the browser itself. So normally, right, when you launch Chrome, you hit an icon on your desktop. It fires up this window. There's very much a UI surface for the user to play around with. They can input a URL. They can open menus, input information into a page and navigate to places. So it's all very manual. You can even open the dev tools and tweak a page on the fly, right? Tweak styles or throw network emulation or get some diagnostics and performance information about your page. And that's Chrome itself. But with Headless Chrome, there's none of that, right? So there's something going on up in the corner. Chrome is actually running. Like you hit the icon, you launch Chrome, but it's invisible. It's in the background. It's in this headless mode. So that's really what Headless Chrome is. It's just Chrome without Chrome. It's Chrome without the UI to interact with. And so the way you launch Chrome in this invisible headless mode is you just throw on this flag. You launch Chrome from the command line. --headless will actually launch Chrome, but you're not going to see anything. It's in this headless mode. By itself, this isn't that useful, right? If you can't see anything, how do you interact with it, right? What do you do with it? And so that's where this second flag comes in, this remote debugging port flag. And when you combine these two, that's actually where the magic happens. So this is launching Chrome in headless mode, but it's also opening up this remote debugging port. And what this is going to allow us to do is actually control Chrome programmatically through the DevTools protocol. And the DevTools protocol is this huge kind of API surface that the DevTools itself uses to communicate and control Chrome. So like anytime you tweak a style or something in the DevTools, it's actually just using this protocol under the hood. So we can tap into that too by using this flag. And you can pass any port you want here. 922 is, you'll see that all over the docs. That's typically one we use. But once you do this unlocks a number of interesting, awesome things. The first thing that I really get stoked about is a testing tool. I said the word testing. Is a tool that stays up to date with the web platform. So we have Blink, right, which is Chrome's rendering engine. It's got all the latest ES6 features and CSS features and JavaScript features. We can actually write automation scripts and testing scripts and even test our real app that use all these latest features like Service Worker and push notifications. Other things to consider, you may not need a JavaScript library like JS DOM for testing the DOM. You have a real DOM in the browser that's implemented. So you can use some of that stuff and test against that now. The other cool thing is that we have programmatic access to the DevTools. So literally, most things you can do in the Chrome DevTools manually, you can actually get access to programmatically using the DevTools APIs and Puppeteer. So all that stuff, network throttling, device emulation, code coverage, like DevTools has a lot of goodies in it, and we can actually write scripts that automate a lot of that. So if you want to know more just about Headless Chrome, check out this article. It's pretty old at this point, but it's still very relevant. You can totally use Headless Chrome without ever having to write code. You can take a screenshot from the command line, navigate to URL, take a screenshot, create a PDF from the page, do things like dump the DOM, size the window. And there's a couple other flags that are interesting. But by itself, there's only so much you can do just without having to write any code. So that's headless browsers. Quick introduction, basically browsers without the Chrome. So maybe you're sold on it, sounds cool. What can you actually do with it? Well, we'll go one level up on our pyramid of Puppeteer. So we got the browser, right, with all that web platform goodness, all those APIs and stuff we can take advantage of. And on top of that is the DevTools protocol. And it's a little bit bigger just because there's so much there. DevTools does a lot of stuff, as you guys probably know. So it's a little bit bigger than the Chrome layer. So these two together is kind of magic. I actually rank this among the greatest duos of all time. So you have like Batman and Robin, obviously Han and Chewie, PB&J is a good one. But Headless Chrome and DevTools, when you combine those, that's where the adventure actually begins for us as programmers. So DevTools, what the heck is DevTools protocol? I had never seen DevTools protocol really until when I started to play with Puppeteer. And it's just because it's pretty low level. It's a really kind of low level API, and there's a lot there. As you can just go to the documentation and browse it, you'll see there's a lot of things you can do. But at its lowest level, it's basically just a WebSocket-based JSON API. So you open this WebSocket with that port that we talked about. You launch Chrome with that port, and that's where you reference it here. And then you can just listen and pass messages to and from Chrome. So this example here basically just sends the runtime evaluate method, which says inject this code into the page and give me the result back. So here I'm just printing out the document's title. What is the title of the page? And that's the message I get back. Parse it out, console log the result, and that's a quick example of just getting the page's title. So that is it. It's pretty low level, right? You have to do all this stuff that's going on, and you can actually see some of this action in the DevTools itself. There's this cool new protocol monitor panel. You can throw that on, and as DevTools, you're like editing things or modifying the DOM or throwing on the network emulation or something, you'll actually see this traffic go across the wire. So you can actually learn the API and see what DevTools is doing as you modify the page. So that's pretty valuable if you're just tapping into the raw protocol itself. So we've got the browser, right? ES6, CSS, HTML, all those features. DevTools protocol that adds layers on top of that to control Chrome and do things with it. And this is where Puppeteer comes in. So we didn't want to have everybody kind of bang on the DevTools. We wanted to create one level up, an easier kind of high-level API surface on top of all this work that's already been done for us. So this is where Puppeteer comes in, and Puppeteer is a node library that the Chrome team has been working on. It's actually built by the DevTools team itself. So DevTools team, they build the DevTools, they build the API, they build this library. They very much know how to build DevTools. They're very good at it. But we wanted to create this library, an easy kind of way to use Headless Chrome and Chromium. Like last year when Headless Chrome came out, there wasn't really good options for working with Headless Chrome. It was still pretty new. So you can get this thing off npm install it, and you're going to see a lot of kind of new features, like ES6 features, if you look at the code or my demos that I'm going to show you today. You'll see a lot of async and await, and that's just because promises are all over the place. We're dealing with WebSockets that we just talked about. We're dealing with node communication to Chrome, to the DevTools protocol, so it's all asynchronous. And promises are great for that, but async and await really clean that code up quite a bit. But if you can't, you can use, if you don't have like Node 8, I think is the latest that has async and await, you can use Node 6, so you don't have to transpile Puppeteer or compile it or anything. You can kind of just use it out of the box. We also wanted to create a kind of zero config, no frills way to use Chromium. If you've ever tried to do automated testing on like Travis or like a CI server, you have to like configure Chrome, find it on the system. If you're running a script across multiple platforms, you have to figure out where it is on the platform. We didn't want you guys to have to deal with any of that. So what we do is we actually bundle Chromium. I think it's Chromium 68, a pretty modern version of Chromium with Puppeteer. So you download Puppeteer from npm, you get a version of Chrome that's guaranteed to work with that version of the API too. So things aren't like shifting from under you. And so that actually saves a lot of time, a lot of headache for finding and launching Chrome. The other thing is high-level APIs, which we'll see just a bunch of cool demos. Again, the WebSocket-based API is great, but that's not practical always. We want to show people how to put these amazing kind of APIs together, and it's not immediately obvious from the DevTools docs how you do that sometimes. So we wanted to create a reference implementation for the power of the DevTools. So let's take a look at the API. One of the most basic things people want to do is let's just take a screenshot of a page, right? So to do that, we'll call Puppeteer launch. This is going to launch Headless Chrome by default. And again, everything is a promise. So this is a promise that's going to resolve to give us a browser instance that we can then interact with. So we have Headless Chrome. It's running. It's fired up. Next thing we need to do is just open a page. So browser.new page will open about blank, just a new tab in Chrome. And it's a promise too, so you're seeing async and await here. We're waiting for that promise to resolve. Once we got our new page open, we can navigate to a URL. Example.com is a great one, using page.go2. And this will wait for the page's load event to fire before moving on. So new page is open, it's ready to go, and then last but not least, we can take a screenshot. So there's a screenshot API. It's got a lot of stuff in it. You can do full page screenshots. You can do portions of a page. You can do actually just screenshot a particular DOM element, which is kind of cool. And it can just save that file to disk, PNG, JPEG, whatever image format you want. And lastly, of course, if you're done, you can just close out the browser. So all in all, it's like 4 or 5 lines of code to do all that stuff. Launch Headless Chrome. You don't see any remote debugging port or anything like that here. You launch a new page, you navigate, wait for its load event, take a screenshot. Don't have to deal with buffers or anything like that in Node. So this is what I mean by high-level APIs, like very task-driven things, easy to use, very self-describing code. So there's Headless Chrome. And this is what Puppeteer uses by default, because we think that's most useful for automated testing. And so when you call Puppeteer launch, it's going to launch Headless Chrome, and you're not going to see anything, which is totally fine. But there's also head full Chrome, so Headless Chrome and head full Chrome. And this is just normal Chrome. We just, it's funny, head full Chrome. And you can use head full Chrome just by throwing on headless false when you call Puppeteer launch. And that's going to launch Chrome. You're going to see a window. And this is actually pretty cool because you can see as you automate a page, you can see Puppeteer clicking around, or there are input APIs. You can see Puppeteer inputting information to a text box. And so it's useful if you're like debugging your script, like you have no idea what's going on because you can't see anything. Just put this on. It'll save you a lot of headache. Back to the architecture diagram, we got the pyramid of Puppeteer, browser, DevTools, Puppeteer on top, shimming and having a high-level API and all that stuff. And at the very top is where our scripts are going to come in. So this just goes to show you there's a lot of work that's been done over many years, and now we can take advantage of all that stuff. So thanks Chrome and DevTools team. So 10 awesome things, and of course there's many more, but 10 awesome things you can do with Headless Chrome. First cool thing that I found is actually you can pre-render a JavaScript client-side application. Right? We have a browser. It knows how to run JavaScript. It knows how to populate HTML, run CSS. Why not take advantage of that? If you don't have a good server-side rendered solution for your client-side app, Headless Chrome might be a good option. So I wanted to see if this was viable. I actually built an app with the idea that I wanted to server-side render this app using Headless Chrome and present that to the search engine so it could crawl my content. So I built this app. It's called the Dev Web Firehose. It's basically this content aggregator of all the stuff my team does, all the articles we write, the samples, tweets. It all goes here. And you can see it's a client-side app. It's got this refresh cycle thing. It's got pagination. It's using some new features like ES modules and lit HTML and Firestore. But the cool part is it runs on Node, on App Engine, and it uses Headless Chrome to pre-render this client-side JS app and pre-render that for search engines. So let's dive in. Let's see how this app is built, and we can kind of discuss the Puppeteer side of things. So index.html, it's a client-side app. It's just this blank container that gets populated with a list of JSON. Fetch the post from my handler, and then render the post inside of this DOM. And render post is pretty trivial, right? It's just this little creates this list of template literals, and then inner HTML is the result. So JSON, fill a container. And that's the goal, right? We're filling kind of an empty container at page load. This is what the page looks like. And ultimately, we just want to pre-render or generate this markup. That's the end goal of pre-rendering your JavaScript app. So we can do that with the browser, with Headless Chrome and Puppeteer. So here's a little method that does that. We'll call it server-side render, and it just takes the URL that you want to pre-render. We'll do the same stuff that we did before. We'll launch Headless Chrome, open a new page, and we'll navigate to that page. And of course, Chrome is going to load the page. It's going to run its JavaScript and anything that the page has on it. Something I've changed here is this new parameter is wait until network idle 0. So before we were waiting for the load event, now we're saying I want to wait even longer. I want to wait for all network requests to be done before resolving. So that's kind of an even better indication the page is fully loaded and ready to go. And the magic is actually this one. So page content will give you not the as authored version of the page, but actually the stringified kind of live update, the snapshot of the current DOM of the page. So it's not the view source version, but like actually the version as run through Chrome. So this is what we then return. It's the new version with that markup injected into the page. So we can take that and actually put it on a web server to do server-side rendering. This is the overall picture here. We'll just have that web server in the cloud. It'll call into Headless Chrome inside of our web server. Someone's going to visit our app, and the server's just going to make a request for that page. We're going to call server-side render method with that URL, just the same URL they hit. Of course, what Chrome is going to see is this blank page, but it's going to then run JavaScript and populate the post all on the client side. And the thing we actually return in our server is that new version, the page content version with the populated DOM. And so then we're server-side rendering this client-side app on the fly using Headless Chrome in the cloud. So the server itself is pretty easy, and this is kind of a bare bones version of it. And by the way, I'm using MJS. I'm using ES modules here, which is now supported in Node 10, I believe, fully. So you see MJS is the file format, but you also need to run this server with the experimental modules flag if you want to actually run this, because I'm using imports instead of requires. So you have a little Express server, and basically listen on port 8080, and then when somebody visits my home page, we'll just do exactly what we described. We will use the server-side render function to render that URL and return the result as a 200 OK for our server. So you guys are probably thinking, like, cool, that makes sense. But is it fast? Is it actually a viable solution to run this in production? So I was very curious about this because yes, you can do this. You can pre-render pages using Headless Chrome in the cloud. But if it's not fast, nobody's going to actually do it, right? So if you actually tweak it down, if you tweak a throttle connection down to about 400 kbs, kind of a mobile device, slow down your CPU to really mimic a mobile device, pre-rendering looks like this. So you'll have the server-side rendered version that goes through Headless Chrome on the right, and the client-side version, just the normal app on the left. Now what you see is the server-side rendered version happens really quickly. You get that first paint, that first contentful paint very quickly because that markup is just in the page when the browser renders it. The client-side version takes a little time, right? It's got to get the initial page, it's got to fetch the post, it's got to render the results. So that's where the delay comes from because we have this slow now mobile connection. So already a performance win just by introducing Headless Chrome into our equation. But the numbers actually speak for themselves. So if you take a look at that app on web page test on a 3G connection, we go down from 11-second first meaningful paint to 2.3 seconds first meaningful paint. So that's a huge improvement just by tacking on Headless Chrome to this application. And first contentful paint, for those that don't know, that's basically, for this app, it's how fast is that meaningful content in the user's face. And in this case, it's just that list of posts that the app renders. So that's awesome. Not only do we get a performance win, but we have a server-side render application that search engines can then crawl because it's just static markup that we're returning. So to get there, I had to do some more stuff. I don't want to pretend like there wasn't other things that I had to do. But I think it's actually worth going through some of these optimizations because it highlights some of Puppeteer's APIs. The first optimization is you don't have to wait for the entire page to load. So what do I mean by that? Well, if we go back to our server-side render method where we launch Headless Chrome, we're actually waiting for all the network requests to be done with this network idle 0. So as long as there's no network requests for 500 milliseconds, it'll then resolve and move on. But if you think about it, we don't care about all the requests. We don't care about analytics requests at the bottom of the page or videos or iframes or something that happens far, far away in the page. We only care about how fast that HTML is in the page, right? We care about the DOM that's generated by the JavaScript. So instead of waiting for network idle 0, we can actually just change that to just resolve this promise after DOM content is loaded. And then combine it with another Puppeteer API called waitForSelector. And what this is going to do is it's actually going to wait for this element based on its CSS selector, this hash post, to be in the DOM of the page and visible. So when that shows up, right, we can then move on. And now I'm kind of changing this method based on the architecture of my app, but I built both of these things, so I know it very well. But you can kind of speed things up that way. You can kind of speed up your server-side rendering based on what the app actually has in it. The other thing is kind of an obvious one, right? Cache the results, right? We don't want to fire up Headless Chrome, waste memory, waste bandwidth for every single request that happens. So the server-side render method, basically, we can just wrap that in a cache. The first time we see a URL, we'll do the Headless Chrome thing where we render it, we pre-render it, stash that in the cache, and then subsequent requests will just basically return that to users. And this speeds up things quite a bit. So it goes, I think my app was like a 1 second render time. And this is, again, only the first time you ever see that URL. So it's a lot faster. Keep in mind, this is a really silly, stupid implementation of this, right? If my node server gets restarted, this cache goes away. You would want to do something more persistent, maybe be a little smarter about when things in the cache get evicted and updated. But that just goes to show you it's a lot faster when you wrap it in caching. Number 3, prevent rehydration. So what the heck is rehydration? So if you go back to just our client-side app, right, we have this container that gets populated with a bunch of JSON posts. And that's what this JavaScript at the bottom here does. But this happens when the user visits the page, right? This JavaScript does its thing in the browser, but it's also happening in the cloud when Headless Chrome runs this page in itself. So we're doing this twice. We're rendering these posts twice. So that's kind of wasteful. The easy way and simple way I decided to deal with this was basically detect if that content is already in the page. When I load this page, I can look for that post div. And if it's there, I know I've been server-side rendered because that markup is in the page. If it's not, I can go ahead, make the fetch request, render my posts, do the client-side version of the page. So that's preventing rehydration. Number 4 is to abort non-DOM requests. What are I'm just making up all kinds of terms. Non-DOM requests. So this is kind of an interesting one. It shows a really, really powerful feature of Puppeteer and the DevTools itself. So using network interception, we can actually intercept any request before Chrome ever makes it. So this is kind of cool because you can change things on the fly. You could literally like rewrite a URL on the fly and issue another request than what Chrome wanted to fetch in the first place. So we can do that in Puppeteer. We can throw on set request interception to true, which means I want to listen for all request events. So on the page object, we'll listen for all network requests. And inside of that, I basically set up this whitelist. And if you think about like what can actually build a page, right? Like script can build a page using the DOM APIs, and XHR can fetch script and build a page using JavaScript. But things like a video tag or a style sheet or an image, they don't actually participate in constructing a page. They don't have the ability to do that. They just style it or present media. So those requests are actually wasteful. We don't need to make those because they don't build the markup of the page. So that's what I've done here. I basically constructed a whitelist. If you're one of these types of resources that can actually build markup using DOM APIs, we'll allow you to go through. We'll continue the request. And if you're like a style sheet or an iframe, or not an iframe, like an image or something, we'll just abort the request. So in that case, we save a little bit of speed. We don't issue all the requests unnecessarily, and you can actually speed up your pre-render using this technique as well. And it's kind of a cool example of using network interception. Another cool thing to do is not do something like this where you inflate your Google Analytics page views, right? You can look for, when you're pre-rendering yourself on the server, you can say, hey, is one of my URLs, is one of my network requests for analytics? And if it is, just abort that, because I don't want to record 2x the amount of hits otherwise. So that's kind of one of the downsides of this approach is that you might be adding more requests or more analytics to your actual your pages. So be careful with that. Last but not least is actually reuse Chrome. So you can launch Chrome every time if you want to, but we also have the ability to, if you want to, just launch Chrome once, right? When your server starts up, launch Chrome using Puppeteer launch, and then on subsequent requests, when people hit your app, you can basically just reconnect to it using that same kind of JSON-based WebSocket API. And so one instance of Chrome, you don't have to fire it up every time, waste memory. You can have a bunch of requests or a bunch of servers kind of communicating with the same Chrome. That's another potential performance win. So that was a lot of stuff. There's more in this article. I encourage you to check it out. There's actually other cool optimizations that I made, some other discussion points, things to consider, everything you want to know about pre-rendering using Headless Chrome. Pretty interesting and cool stuff. And the coolest part about that actually is I didn't really change any of the code in the app. It was just a client-side app. I just kind of added on Headless Chrome in the cloud and got performance and server-side rendering for free. So that's why I dig it, because I'm lazy and I don't want to do other stuff. Number 2 cool thing you can do is actually determine if lazy loading is working. I build apps, I build demos and stuff for people to learn from. And one of the things I always wonder is like all this extra work I'm doing for performance, like lazy loading and stuff, is it actually meaningful? Is it paying off? Like, am I wasting my time? And once I go down that route, it's hard to know like what the other version of the app could have been, right? Like, how do you do that A/B test? I said testing again. I know. But one thing you can do actually is determine that using and writing a script in Puppeteer. DevTools has this code coverage API, and there's a cool panel for it where you can kind of see the percentage of the JavaScript and CSS of a file, the resource that gets used. So you can determine, hey, maybe I'm throwing way too much JavaScript down the wire. I'm not using half of it. That's very wasteful. So that's a good tool for analyzing things. And we can tap into that programmatically, too, with Puppeteer's code coverage API. So we can start recording and stop recording anytime we want. Maybe navigate to a URL, click around, whatever invokes kind of your lazy loading stuff. Stop the code coverage and then analyze it. And so one thing you can do is kind of analyze how things load over time. This little script here basically just does that. We'll visit a URL, and over the course of the page, at DOM content loaded, at load, and when the page is finally loaded, we can kind of analyze the breakdown of the files being used. So this example here, I'm visiting Chrome status, and this little table shows you that at DOM content loaded, so very early in the page, I'm using about 37% of the JavaScript and CSS of these files. So not very good, but you'd expect that. It's early in the page. But by the time we get to fully loaded, I'm using about 67%, so pretty good. What I like about this is it actually shows you that this app is lazy loading stuff. So this resource here, this second line, this vulcanize.html, is an HTML import. It's a Polymer-based application. And you can see that none of the resources are actually used at all in this app. So for this resource, at these different points in time, I've used none of the app, and that's because we've seen this URL through network interception, but we actually haven't used it. So this resource is behind a user click. When somebody clicks this navigation bar at the top of this app, it then loads this resource. So you can write cool scripts like this, command line scripts, to really automate things and determine if, hey, is lazy loading actually worthwhile? You can combine this with other page performance metrics to determine if you're wasting your time or not, or maybe spending too much time trying to micro-optimize things. This is a cool project worth talking about, Puppeteer to Istanbul. If you're familiar with Istanbul, the community threw together this. You can get off of NPN, and basically takes the output of the code coverage API, and it dumps it right into one of these awesome Istanbul reports. So it's a little easier to analyze than just a bunch of numbers. There's testing again. Damn it. OK. So number 3 is A/B testing. But I don't really consider this testing. I think this is more about showing kind of live modifying a page on the fly and doing kind of analysis between the two versions. I guess that's A/B testing, but whatever. So the idea here is, hey, can we determine if inlining critical styles is actually better for our app than just having regular style sheets? That's what I want to do, and I want to have 2 different versions of the app. And without having to change the code and kind of ship 2 different versions to production, I want to just do this using Puppeteer and Headless Chrome. So we'll actually use network interception again, but instead of listening for request events, I want to know when responses happen. So I want to get all network responses. And inside of this callback, I'll just pull out any style sheet I see. I'll just stash the URL, and its value will be the actual content of that style sheet. So just the CSS in that style sheet. So I'm just stashing style sheets as they get issued and as they happen and get loaded by the browser. Now, we want to actually analyze a page, so we'll navigate to the URL that we want to do this kind of comparison for. And then the third one is a new API that we haven't talked about yet, which is $eval. This is kind of like a jQuery-like API. It takes a CSS selector. So in this case, I want to grab all of the style sheets on the page. And this callback here is not going to be run inside of Node or Puppeteer code. It's actually going to be injected into the page. So this content is going to be run in the page, which means you can use anything in the browser, right? The DOM APIs, web platform APIs. So again, this is not in Node. It's in the actual browser. And what I'm doing here is basically just creating, for every style sheet that I found on the page, I'm replacing it with a style tag, an equivalent style tag, and setting that CSS content to the content of that style tag. So I'm basically inlining the styles on the fly, right, for every style sheet that I found. And then last but not least, you would want to then do this actual comparison in some real app or some testing environment. You've modified the page on the fly, you've inlined the styles, then you would measure how fast your page is after that change. So live modifying a page, A/B testing. Number 4, cool thing you could do, catch potential issues with the Google crawler. This is an interesting one. So I built that app, that Firehose app, and actually discovered that Google's search bot runs Chrome 41, which is a super old version of Chrome. That's like a couple years old at this point, which means it has no new features. Which means that if you're using features like CSS custom properties or ES6 modules or any of this new stuff, there's potential that your page is not going to render correctly for Google search. So that's like a big WTF, right? Like I actually had to push this app to production. I had to push the render as Google button and only found this out after I shipped my app. So I wanted to know if we could write a Puppeteer script that actually caught some of this ahead of time and maybe flag some potential issues. And sure enough, you can do this. So if you guys have ever used the DevTools timeline, right, you can press that little red recording button, start a timeline trace. You'll see a bunch of waterfall action, a lot of diagnostics about the page as it gets loaded and you do stuff. We can also do that in Puppeteer using the tracing API. So we start a trace, we'll go to a page, do a bunch of stuff, whatever. Maybe we just care about the loading of the page, and then call page tracing.stop. And so what you get back is this big JSON file. There's a lot of stuff in there, everything about the page that happened in that period of time. And one of the cool things actually in that JSON file is all the features the page used. So any HTML features or JavaScript APIs you called or CSS features is going to show up in this trace. And we can correlate that with can I use data for Chrome 41. And so this script does that. Basically, you go to this URL, any URL you want, and it'll tell you the list of features that the page used, which are not available in Chrome 41, which means that, hey, some of these features, if they're related to rendering, like properties or CSS contain or something, could potentially make my app not work correctly when it's being rendered by the Google bot. So you can see Chrome status uses HTML slots, it uses web components, it uses the cache storage API. I'm using CSS contains, service worker, some other features. So this is a kind of cool thing because I don't have to push this app to production to discover this, potential issues. I can determine this ahead of time, decide maybe, I might not have needed a polyfill before, but maybe because of the Google search bot's old clunkiness, you might have to load a polyfill we didn't expect before. So that's kind of cool. We can catch potential issues with the crawler. Number 5, create custom PDFs. So at I/O this year, how many people were at I/O actually? Okay. I think I was at I/O too, so that makes like 2 of us. So at I/O, we had this big Lighthouse. If you guys know the Lighthouse tool that we have in DevTools, the performance tool, we had a physical Lighthouse where people would come up and enter their URL inside of a laptop. And what we did was we basically used Puppeteer to run multiple performance tools all at once. So we ran web page tests, Lighthouse, and PageSpeed Insights all at once. And we used Puppeteer to orchestrate all that, just spawn up a bunch of pages. And then we aggregated all the reports, each of the separate reports that you got from those tools, and created a web page on the fly, and created a PDF for people to take home and kind of take back to their CTOs or whatever. And so basically, we're creating a custom PDF on the fly using Puppeteer and Headless Chrome. So this is kind of neat. Basically, it's pretty easy. We'll just create a new page, right? Create about blank. And instead of navigating to a page, we're just going to create one on the fly using page content. So just plop in an HTML string and build your page that way. So you can include anything you want here. Instead of creating a small page, by default, we emulate a mobile viewport. We just use device emulation called page set viewport and make it a bigger page with a proper device pixel ratio for the machine. And then similar to the screenshot API, we have a PDF API. You can pass it the name of the file that you want to create. And this takes a bunch of options too. You can do headers and footers and margins and basically anything Chrome's PDF system can do. You can do programmatically too in Puppeteer. I don't know why people like to create PDFs of their pages, but a lot of people do, and it's a very popular API. There's a lot of bugs with it too, but they're not our bugs, they're Chromium's bugs. But if you find them, file them and let us know because it is such a popular API. And so yeah, instead of needing a node library to create PDFs, we can basically just use the tool on our system, which is the browser, to do this now. So that's how you can create custom PDFs on the fly. Number 6 is a cool one, kind of a silly one, but it shows kind of bridging the world of Node and Puppeteer with the power of the web platform. So I have audio for this one. I think they're going to turn it up. What's going to happen here is this script is going to read a text file, this message.txt file, and it's going to inject that message into a page that Puppeteer opens. And then using the web speech synthesis API, the page is going to read back this message that we've injected back to us. So again, combining kind of Node and scripting with a feature in the web platform, which is the web speech synth API. Let's see.
Hi there, my name is Puppeteer. I've clicked the speak button on this page to start talking to you. I'm able to speak using the browser's web speech synthesis API and a message injected into the page from Node. TLDR, the rise of the machines has begun. Bye for now.
So we're not quite there with the rise of the machines, but it is a cool illustration of combining these two worlds. So how do I do this? Well, the first thing I want to highlight is you did see a window, right? We used headful Chrome there. It was a little window. I'm using a couple other Chromium command line flags, so we're basically sizing it to be 0, 0, which means make it as small as possible, and position it in the top left corner. And we're also using headless false. So I'm launching that window. And the reason for that actually is because the web speech synthesis API is not available in headless Chrome. So you need full Chrome to actually do the audio for that. The other thing I'm doing here is I'm using another parameter which we haven't talked about, which is the executable path. And so I actually launch the Chrome that's Canary or stable or beta channel, but like an official version of Chrome, instead of the one that is bundled with Puppeteer, the Chromium version. And that's because the open source version of Chromium doesn't have that cool British accent in Chromium. I wanted the Jarvis, so I had to do an official version of Chrome for that. So those are the two different things for the launch command. So once we got this little browser window launched, basically this page just has a bunch of code, a little bit of code in it to use the web speech synthesis API to read back that text. So how do I get that text inside of the page? We'll create the new page, and we'll use this evaluate on new document. This is another Puppeteer API, which is going to allow us to actually inject and run this code before any of the code on the page runs. So we're kind of setting things up. This is our init code, if you will, for the page. And what I do is I drop in a global variable, call it text to speech, and I set it to that message from the file we read in Node. Hi there, my name is Puppeteer. And that's how we get the message into the page. Another pro tip, I didn't actually start a web server for this demo. I actually just read the HTML file using Node's file reader APIs. And then I used page.goto just to navigate to the data URL of that file content. So you don't have to, in some cases, things work without actually firing up a web server. So I got the page, it's got web speech code on it, and then last but not least, to actually invoke and make Chrome talk, we'll use Puppeteer's page $ to grab a handle to that speak button and actually just click it. And that's what actually fires off and starts the speaking. So that's making your browser talk using Headless Chrome. Number 7, test a Chrome extension. I have no idea how people test Chrome extensions, but one way is to use Headless Chrome and Puppeteer. I want to show you guys an actual example. The Lighthouse team, we have a Chrome extension. You can also run Lighthouse in the dev tools, and you can run it on NPM too on the CLI. But we have a Chrome extension, and sometimes that Chrome extension breaks. We ship bad code or whatever. Sometimes there's Chrome changes maybe that when you hit that button, Lighthouse doesn't actually start up and do its thing. So we wanted to finally write some tests to make sure that never happens again. So what the Lighthouse team did was, I'm just going to run their unit test. We'll run yarn test extension, which is just part of their testing harness. And what's going to happen is that Puppeteer is going to fire up a page to start auditing it with Lighthouse. You can see in the corner the extension has actually been lit up, so we're actually running the extension itself. I'm not using Puppeteer to do this. This is just Lighthouse doing its thing, which reloads the page. You can see the info bar explains that. Lighthouse is debugging the page, and it also shows Puppeteer is automating the page. And really quick, what you saw is there's a report that happens, and eventually their test passed. So they did a good job. We actually run Lighthouse automatically, the Chrome extension, using Puppeteer. So how do they do this? Well, we'll go back to the Puppeteer launch. And when we launch Chrome in this case, we also have to launch it in headful mode because Chrome extensions aren't supported yet in headless Chrome. So we need a window, use headless false, and then we just load the Chrome extension. Just whatever directory your Chrome extension lives in, you load that up. This is just a standard command line flag for Chrome. This list is published on the web if you just Google Chromium flags. So we load the Chrome extension, and that basically launches Chrome in headful mode with our Chrome extension booted up, installed. And what they do is they basically look for their background page. So if you're familiar with Chrome extensions, there's these things called background pages, basically the brains of the extension. So they loop through all the targets in the browser, which in this case we don't have any really because we've only created a new tab. But one of those is the actual background page, the extension itself. So we grab a handle to that extension page, and we actually call one of the methods that the extension has defined inside of it using Puppeteer's APIs. So the extension page, evaluate, and again, this callback gets injected in the page, so we're injecting it into the extension page. And again, this is not a method I've defined in my Puppeteer code. It's actually just part of this extension's app. I just happen to know that this extension has that method. So that's how the button actually gets pressed and Lighthouse starts doing its thing. So to make sure it's actually running. So that's testing a Chrome extension using Puppeteer. Number 8 is to crawl a single page application. So I don't know, why you would want to crawl your single page app. Maybe you want to generate like a sitemap on the fly, or just discover all the URLs in your single page app to make sure there's not a bunch of duplicates or something. See the navigation structure or something. But that's what I did here. I basically wrote a Puppeteer script that crawls this Polymer news site, which is a single-page application built using Polymer and web components, and then use D3 to kind of visualize all the different URLs and all the different pages within that single-page application. This is actually pretty easy to do. We can use $ again to grab all of the anchor tags on the page. I just want to discover all of the links on the page. And inside of the code that gets injected in the page, we'll basically just look for, is the URL part of my app? Is it the same origin as my app? Is it local? And it's not the page itself. So I don't want to call myself and keep re-rendering my page. And you would return the list, and you do this recursively again and again. For every URL you discover, you would run this piece of code. And this is kind of neat because you can do other things. It's not just a list of URLs or a sitemap. You could do something like this where you visualize, and for every page you visit in your single page app, you could take a screenshot or generate a PDF or whatever. Santa Tracker is a really good kind of cool example of a single page app that's very visual. So it's a good example of using screenshots to see all these different cool scenes during Christmas time. But that's crawling an app using Puppeteer, discovering all the URLs in your site. Number 9 awesome thing is verify service worker is caching your stuff. How many people have used service worker? How many people hate service worker like I do? No? Right. Service worker is painful. It's painful to use because oftentimes what happens, at least when I build stuff, is I will forget to cache some important JavaScript resource, and then someone will come back to my page when they're offline and it just won't work because I totally just forgot to cache that, or some image or something. So instead, we can use Puppeteer to verify that an entire page is going to work offline. So we can do that. We can just navigate to a page that is meant to work offline. And we'll use page evaluate to actually just wait for the service worker to be installed in the page and ready. So this API here is actually just a web platform API you can run. It resolves to a promise if you run that in the console or the dev tools. And so we're just waiting for that to be ready, which means our service worker is ready to go. We'll use network interception to actually look for any request the page makes. We'll just stash that in a map to know what the URLs the page actually uses. The next thing we need is we want to reload the page. We want to determine what resources, after I reload, and my service worker's done its offline caching stuff, how many come from the network and how many come from the offline cache. So we can determine if our app is going to work offline. And then that's what this last piece of script does. It basically just looks at all the responses that happen for every network request, and it prints out, are they from the service worker cache, or are they from the network cache? They're just made by the network. So that's what this script does here on the right. You can see it would just hit a URL. It'll go visit the page. It'll reload the page after the service worker's cached the page. And for every URL that actually will be served offline, it's in the service worker cache. There's a green little check. And everything that's not going to come from the cache, it's going to be made to the network, it's going to have a red X. So this particular app, I think all of the requests for analytics are not cached in service worker, and that's totally fine. That was a conscious decision in this app. We don't expect that stuff to work offline. But everything else is actually going to be covered by service worker. So we know our entire page or our entire app is going to work offline. There's no surprises anymore with service worker offline. There's also a cool API, just a one-liner. If you want to just turn off the network connection in Puppeteer and just test things and how your app behaves offline as you navigate around or do click or something, you can use set offline mode to true, and then I'll kill and throttle down the network connection to 0. So number 10, and the last cool demo I have for you guys is basically to procrastinate. I'm a lazy developer too. But I didn't really have a cool demo to show Puppeteer's input APIs. We have a keyboard API, touch APIs, things you expect, being able to type in a web page and stuff. But what this demo is going to do is basically it's going to open the Google Doodle from a couple of years ago and play that in Node, and we'll just say it's kind of cool. So we'll use Puppeteer. We'll launch the demo app. It's Pac-Man. And basically inside of Node in the terminal, I'm using the keys. So I'm pressing the keys inside of my terminal, and we're forwarding those key presses, those key events, to the page. And of course, the page already has JavaScript in it to handle key presses, so it's just doing what it was supposed to do. But kind of, again, a cool example of bridging the gap between Node and Headless Chrome to do something silly like waste time and play Pac-Man. Clearly, I'm not very good. All right, so before we wrap up, I want to just share a couple of useful resources that we threw together to help you out and to learn Puppeteer and kind of illustrate the things you can do with Headless Chrome. So the first one is like the browser as a service, so the browser as web services. This is kind of a cool example site we put together, Puppeteer as a service. It runs on App Engine. It just runs Headless Chrome. And for all these different URLs, it's kind of examples, right? You can hit this URL and actually generate a screenshot on the fly for any URL, or create a PDF on the fly, do the Google search bot sanity check and some other stuff. So you can actually run Headless Chrome not as like a performance tool, but you can do it as part of your web service, as part of your kind of your web app. And so that highlights the browser as a service. All the demos and examples I showed, as well as some other ones, are up on our Google Chrome Labs GitHub repository. So check that out if you see any bugs, or if you want to see other demos that are useful to you, how you do something using Puppeteer, file those. I'm happy to create them. I can't think of everything, I promise you. Try Puppeteer is a cool little toy project we put together, kind of just allow folks to try out Puppeteer's API before you have to ever install anything. So you can visit this URL, you can try our official examples in the GitHub repository. It's kind of cool. You can actually see the results. If you print anything to the console, it'll show you up top. And screenshots and PDFs you'll see the result at the bottom, so you can kind of try it before you buy it when using Puppeteer. So a lot of stuff today, actually. I mean, we actually covered a lot in what the DevTools can do, but there's obviously a lot of stuff in our docs and stuff that you can't cover in 40 or 50 minutes. But things like taking a screenshot, offline testing, injecting code into a page, evaluating code into a page, code coverage, performance testing. I keep saying testing. Testing's good. We should all do it. Headless Chrome in the cloud, server-side rendering your single-page applications using Headless Chrome. Render is Google, the sanity check to make sure your app is actually hopefully going to render correctly in the Google search bot. Network emulation, viewport emulation, just a ton of stuff. So hopefully it's all about automation. That's the name of the game. It's not about testing. Chrome can literally be a front end for your web's front end, as you saw in the example, the server-side rendering case. Again, it's at eBidle on GitHub and Twitter. Feel free to hit me with questions. We'll stick around later for questions as well. And I'll throw this one up there. This is a good one to take a photo or a screenshot of. So with that, I think I'm done. Appreciate everybody sticking around. Thanks for coming out.